Welcome back, everybody. This is part 3 of our Sectors of a Circle Lesson 22 homework review. And so again, we'll emphasize the fact that a lot of this, whether it be arc length or area of a circle, has to do with our central angle. So that tells us what portion of the circle we're dealing with. Now we also need to know whether we're dealing with the arc length, the circumference, or we're dealing with the area sector, which is just a part of the area circle. So an end crawls around the perimeter of a circle. So you can draw a circle if you want to. And so I'm going to pop a circle here. And in this case, it says here that I'll move this over here a little bit aside. And so it says here, the radius of the circle is about 2 feet. So here's going to be our center, and I'll draw a radius here. That'll be 2 feet. Okay. So then it says here to crawl a central angle of 72. Now 72 is probably around something like this much. All right, so let's label some of these things here. Okay, so here we have 2 feet. All right, and our central angle, that'll be, in this case, 72 degrees. So 72 with a little O here, and I'll just make this, bring this up, make it look like a degree symbol. Okay, and so I'll put this right here. Okay, and so the ant's walking around this circle, and so the portion of the circle it's walking around is going to be this part here. And so this is an arc length, and so our arc length, we know, should be the central angle over 360 times 2 pi r. So that's the circumference of the circle. And so the circumference we know is to be 2 pi r, and so we have 72 degrees over 360. So there's a fraction of the circle here, times 2 times pi times 2. Now, here is the thing. 72 over 360, 72 goes to 360 5 times, so 1/5 times 4 pi. Or in this case, 4 pi over 5 feet. That's exact value. But to the distance to the, now wait a minute though, nearest inch, very important, because now we have a unit type situation. So this really is going to be 4 pi over 5 times 12 inches. Okay, so now we're going to break out our calculator. Because again, very important, we were dealing with 2 different units. We'll figure out what we're looking for to nearest inch. So we're going to take 4 pi, so 4 pi divided by 5, right? And then times, we said in this case, 4 pi over 5, which was the first part, times 12 inches. So we're going to multiply that by 12, times 12. And this will give us our measurement in inches, 30.1592847. So about, in this case, approximately, to nearest inch, 30 inches, to nearest inch, 30 inches. So that's going to be the value we're having here. Now, very important to keep in mind that in this situation that we had to convert everything into inches by multiplying our value by 12. So yeah, in this case, we got 4 pi over 5, which again, it's like 0.8 times 3 by 2, which is about 2.4, a little more to 4, and multiplied by 12, 2.4 actually? No, that doesn't make any sense. Hold on a second. 4 pi over 5 times 12. Let's see. So 4 pi over 5 times 12. Yeah, so about 30 inches. So that's what just in this case we find our value in feet times 12. Okay, so we get 30 inches. All right, so that should make sense. Just want to double check and make sure. So my numbers and all. Just want to make sure. Okay, so let's continue. So our last question is going to be question number 7. Isosceles triangle ABC is shown below with legs that measure 8 inches and a vertex angle of 50 degrees. Determine the area of triangle ABC. Note that you need to use right triangle trigonometry, or if we know how to find the area of a triangle, we can go around that. But we'll do the right triangle trigonometry as well too. Then we'll find the area of the sector, and then using A and B to find the area of the shaded region, which we talked about being a circular segment, or so we're going to take the difference between two of them. So first for A, so now consider we have this isosceles triangle here. Okay, let's draw a little triangle here, isosceles triangle. All right, and so we're going to drop an altitude going down from here. So we drop an altitude, and this altitude drawn from the vertex angle of the isosceles triangle is going to bisect the angle. So if the vertex angle is 50, then this angle here for this part is going to be 25 degrees. And that being the case, we know that this measurement here would have to be, this angle here would have to be here 65 degrees. Now, it doesn't matter which one you want to use. You mean 25 or 65, that's fine. But we use 25, that's totally good. We know this measurement's 8, and we want to find this measurement here. And so we'll call that x. We'll double that to find the base. And then we'll probably need to find the height as well, too. So that's the interesting part as well, okay? So here we go. So now I'll call this y, all right? And so here, by using trig, we can use, this is 25 degrees. So we have here the sine of 25 equals x over 8. Therefore, so it's opposite over hypotenuse. Hypotenuse is 8, and the leg opposite of the 25 degrees is at x. And so now we get x equals to the sine 8 times sine 25. But our base here is 2x. So our base is equal to 2 times 8 times sine of 25. Now our height, which we call y, we'll use cosine. So we have the cosine of 25 is equal to y over 8. And therefore y is equal to 8 times cosine of 25. And that's our height. So h equals 8 times cosine of 25. So the area of the triangle is 1/2 base times height, which means you're going to take 16 sine of 25 times 8 cosine of 25. Whew, okay, let's break our calculators to find the area. So we said 16, so 16 the sine of 25 times sine of 25. We'll close a parenthesis there to close off the angle, times 8 cosine of 25. And I forgot one other thing. We have to divide by 2. So because the base and height are going to be, in this case, 16 sine 25 times 8 cosine 25. And we divide the whole thing by 2 to get the area of the sorry about that, to get the area of the triangle. So that gives us 24.5. So divide by 2, got that there. So that gives the nearest tenth of a square inch. We said 24.5. So 24.5 inches squared. Okay, so this is going to be the answer for part A, 24.5 inches squared. Now, is there a faster way? Of course there's a faster way. We learned how to find the area of a triangle. So allow me to erase all this stuff. Now, if you want to, you can take a picture of this, just to pause the video, write everything down. You can, no big deal, but I'm going to erase all this stuff here. Oops. Let me just, yeah, so now what happens is by erasing all this stuff here, actually, you know what, I'm going to just do this, just go backwards, and just have everything disappear. So, okay, that's this, going back in time, oops. So let's go back to here. All right, so now, area of a triangle. So for area of a triangle, we still can use our area of a triangle formula. That formula will be, in this case, 1/2 AB sine of C. Or in this case, well, really it's not AB sine of C. Here is going to be 1/2, we will call it BC sine of A. Now, what does that mean? Well, the two sides that make up the B, that's the legs opposite of angle B and C. So the area is going to be 1/2 8 times 8 times the sine of the angle included, which is 50 degrees. And so this is really a lot easier. So let's take a look here. All right, so now we have, in this case, 1/2 times 8 times 8 times the sine of 50. And so this area is going to be, same thing as before, 24.5. Okay? So area of triangle will be done two different ways. Now, let's find the area of the sector. Now, the area of the sector is going to be, in this case, the angle measure theta over 360 times pi r squared, and so pi r squared. So this is going to be 50 over 360 times pi times 8 squared. So we're going to enter that in the calculator. So just straight out, 50 divided by 360. So 50 divided by 360 pi times 8 squared. That's the radius. So the fraction of the circle we have. And so now we get 27.925. So it's the nearest, again, this is the nearest tenth of an inch. Nearest tenth, we said 27 point, double check, make sure, 27.9, about 27.9. Okay, so using the answers we found in part A and part B, all right? So here, we're not going to go back to the exact values. We use our answers, part A and part B, do 27.9 minus 24.5. That leftover area, the shaded region, is going to be 3.4 inches squared, the difference in this case. And so this will be the final answer we have. So the answer part A was 24.5 inches squared. That was the area of the triangle. The area of the sector was 27.9 inches squared. And the area of the circular segment, this little shaded area, is going to be the difference, which is 3.4 inches squared. Okay, ladies and gentlemen, so again, it seems like a lot of these can be solved by using shaded region problems, but we have to be able to figure out how to find our different areas. And so as long as you do piece by piece, hopefully it'll be helpful. Ladies and gentlemen, if these videos are helpful to you, especially for these last questions, please leave a like for the video. Leave any questions or comments below, what you liked about, what you didn't like about it, and all suggestions. We really appreciate that. Again, subscribe to our channel, turn notifications, and you know what? Hope you guys really enjoyed this section. I look forward to seeing you guys again for our next video. Thanks for watching. Take care and be safe.